Hi, in this video I discuss the sampling distribution of the mean. So what we are doing in this section of chapter 7 is estimating the mean for the entire population using a sample. This is what we're doing. So we're trying to determining the mean using a sample, and the problem is we can have different samples, and different samples can have different means depending on the observations we have. Remember from one of our videos in chapter 6, we are talking about the EAI company, and we have the population of 2,500 employees, and the slides have one sample, and I used another sample, and I obtained a different sample mean. And remember, because of that, we can have different means for the same population because we're using different samples. Okay, and because of that, we have a variability of the mean, which is called standard deviation or standard error of the mean, or how much error variability we have in our mean by using a sample. Again, the idea here is you have a population, let's say all students in the School of Business or all students in the College of Charleston, and we want to select a sample. I can select a sample, you can select a sample, another person can select another sample, and there are different samples about the same population, so you can have different means. So this is the reason we have some variability of the mean, and this is where the standard deviation of the mean takes place. Okay, so let's move on to understanding the sampling distribution of the mean. Again, we have a population and we don't know the mean of the population. We use a random sample to get data and compute the sample mean, and then we use this sample mean to estimate how the population mean is. And then because we have different samples, we can have a sampling distribution of the sample mean. Again, get used to the terminology. Sometimes it's confusing, but basically what we have is a distribution of possible sample means, okay, which is the probability distribution of all possible values of the sample mean if we select many samples. Okay, again, imagine if you could take many samples, each sample would have a sample mean, and then we would have a distribution of the sample mean. Okay. Also, we know that the expected value of the sample mean is equal to the population mean. This is proven by the statistics. Okay. Also, we'll be using the following notation to define the standard deviation of the sample mean. So we have the standard deviation of the sample mean. This is sigma x bar. This is how you read sigma x bar is the standard deviation of the sample mean. The sigma is the standard deviation of the population. This, lower capital is the sample size, lower capital N, and the high capital N is the population size. Okay, so every time that we have a sample, we have a sample mean and a sample standard deviation of the sample mean. A standard deviation of the sample mean. And this standard deviation of the sample mean can come from a finite population, and then we use this formula to compute the standard deviation of the sample mean, or if the population is an infinite population, this is the formula we use to compute the standard deviation of the sample mean. Okay, you can see that they are very similar. This one is equal to this one. The only difference is that we add this term if the population is finite, which means the standard deviation of the sample mean is always the population standard deviation, which is sigma divided by the square root of the sample size. And if the population is finite, we add this called finite population correction factor. Okay, and when we use this formula we use a finite population if the sample size divided by the whole population size, the proportion is smaller than 0.05. Okay, so we can compute. You're going to be given the sample size and the population size. You compute that. If it's smaller than 0.05, you use this formula. If not, you use this formula, okay, to compute the standard deviation. Okay, so that's it. Let me I'm going to prepare another video about applying and using the sampling distribution.